Still Chapter 3, Section 4. We're going to be talking about energy. This is going to be in two different videos. The first video is going to be the concepts. The second video is going to be all the example problems. Let's go. Energy. Energy is required to do work. That means to do anything, we need energy. Okay? There are two types of energy. Everything breaks down to these two types of energy. Kinetic energy, which we often say that that's energy of motion. Then there's potential energy. Potential energy, we often talk about stored energy. In physics, you learn about potential energy in terms of gravitational potential energy. So how high or low that object has, and then that potential energy is eventually converted to kinetic energy as it starts moving faster and faster, getting closer and closer to the center of gravity, whatever that happens to be. In chemistry, we talk about potential energy in terms of the chemical bonds or the forces of attraction between particles. So what is energy in chemistry? Kinetic energy is the energy due to the movement of the particles. So the more those particles move around, the greater their kinetic energy. The slower they move around, the lower their kinetic energy. And then we have potential energy. And potential energy is due to attractive forces. For us in chemistry, there's two types of attractive forces for high school. There's chemical bonds, and then there are intermolecular forces or interparticle forces. Those are just attractive forces. They're the same. Bonds are really strong attractive forces. Attractive forces are intermolecular forces. They're just weaker forces of attraction. You can't use those terms interchangeably. You can't call an intermolecular force a bond, and you can't call a bond a attractive force, but they are just forces of attraction. So potential energy due to attractive forces. Two examples here would be a chemical bond. Chemical bond. The second example that I gave there are just attractive forces. I'm going to go ahead and name them intermolecular forces. We won't talk about those again until later on. But just to tell you, when we talked about solids, liquids, and gases, and how solids have really stronger forces of attraction, in that case we're talking about intermolecular forces. Energy is interchangeable but never lost. In other words, potential energy can be converted to kinetic energy, and kinetic energy can be converted to potential energy. That's what we say that it's interchangeable but never lost. So the amount of energy that we start out with is going to be the amount of energy that we end up with. It just may be in a different form. Let's take a chemical reaction. If I take something like hydrogen and oxygen, I can combine them to form water. Now, the energy that we start out with and the energy that we end with has to be the same. The difference is how that energy shows up. In the case of water, we're going to be talking about a chemical bond between a hydrogen and an oxygen. So we may make these hydrogen and oxygen particles move faster until they get to the point where they have a chemical bond, at which point we're converting our kinetic energy to our potential energy. So, as I said, whenever we talk about energy, we're talking about the motion of the particles. We often feel or sense the motion of the particles in terms of heat. Heat is just a measurement of energy, okay? Objects that feel cold, they feel cold because they're moving slower than whatever you're touching them with. So if I were to touch this glass of ice cold water with my finger, the ice cold water is moving slower. And as a result, my finger loses energy to the water. Since my finger is losing energy, my finger feels cold. Why? Because now the particles in my finger are moving slower. Right? If they were moving faster, they would feel hot. My finger would feel hot. The finger. Yeah. So, energy always flows from hot to cold. That is a diffusion pattern. So, energy is going to flow from your finger to the colder object as long as you're touching something colder. Now, if you're touching a hot pan, the energy flows from the hot pan into your finger. And that's why it feels hot, because your fingers, the particles in your fingers are starting to move faster and faster. So, your finger loses energy and therefore feels colder. How do we measure energy? We typically measure it in terms of what's called a joule. Now, you may be familiar with what's called a calorie. Ooh, you can't see that. That was a bad idea. Let's stick with green here. So there's a joule, capital J, and then there's a calorie. As it turns out, for every 1 calorie, there are 4.184 joules. You are used to what's called a capital C calorie, and a capital C calorie is actually a kilocalorie, which we'll talk about when we do some example problems. Right? So the nutritional calorie is related to the energy calorie that we're talking about. It's just that the nutritional calorie is a bunch of these smaller calories. So here's our conversion factor. And again, in the next video, I'm going to do all of these example problems. See you there. Beep, beep.